Awesome, man. Thank you so much for being here. Well, let's get right into it. First, could you introduce yourself and tell us a little bit about what you are working on?
Yeah, so I'm Adam Fish. I am a PhD student, fourth year at CSAIL, which is the Computer Science and Artificial Intelligence Lab at MIT. I work specifically in different areas of machine learning, most often in applications of natural language processing with my advisor, Regina Barzilai. Um, and yeah, I'm excited to be here.
Awesome. Thank you, man. So first, I thought since we kind of did a super comprehensive review last time, it would be cool if I threw some projects, some like very top of the line stuff that's being worked on right now and very integral to our society, and maybe you could talk about some of the processes behind them. So I wanted first to start out with curated social media feeds. So Instagram, they take your personal user data and they basically curate your feed exactly for you to keep you locked in. And I was hoping you could talk a little bit to how that actually functions, how that actually works.
Sure, yeah. Actually, before I went to MIT for my PhD, I worked at Facebook as an research engineer. So some of the things that we worked on back then, which was 2015 around, was different algorithms for ranking feeds, so Instagram included. I mean, the general idea behind ranking algorithms is that, well, you want to figure out what item, if you have, say, a list of many items in Instagram, it would be all the different types of posts that you could be interacting with, or on Facebook, it might be statuses or news articles or really whatever kind of content is being posted to the website that you can't digest all up because there's millions and millions of things. And in order to keep you engaged or in order to keep you happy in terms of what, you're seeing what you want to see versus, I want to see what I want to see and you want to see what you want to see. All of that involves being able to try to automatically sort of be able to, given a list of items, rank them according to my sort of estimated interest in them. So there are many machine learning algorithms which are useful for this. A lot of them, at least on the Facebook level, have to do with things that are basically derivatives of collaborative filtering. Collaborative filtering is basically this algorithm which at a high level is your sort of behavior in the way that it mimics the behaviors of other users that are similar to you, gives you a pretty good probability that what other people who are similar to you like, you will also like. So for example, at least in collaborative filtering, there was a famous Netflix grand challenge where given a whole matrix of movies and users, where one user watched the movie and rated it like in stars out of 5. And then you wanted to basically see, okay, in the movies that a user hasn't watched yet, or maybe we just like pretend that he hasn't watched it yet, but we actually do know, what do we guess this person will rate this movie? Will they like it or not? And so that's like a whole web of like, for example, you can imagine that people who also like Star Wars will also like Lord of the Rings.
Mm-hmm.
People who didn't like Star Wars won't also like Lord of the Rings. It's but now imagine like scaling that out from just like movies to everything that you do, like who your friends are, what you interact with, how you write in similar ways. You can imagine that you can sort of scale this up with many different ways of measuring similarity and measuring basically different ways of trying to guess what people will like to interact with. So that's sort of like the core algorithms behind these ranked feeds or just personalization engines or search engines, whatever have you that has some aspect of ranking or personalization. They all have, different flavors of ranking algorithms behind them. Now, I guess some things that get tricky is, okay, you have a ranking algorithm. Ranking sort of by definition implies that you have some ordering of some objective. So, like for example, if you order the numbers 1 through 10, then they will be ranked according to what their actual number is. But now let's say you wanted to order the numbers from 1 through 10 differently. Like, for example, it was a deck of cards, you now order them by suit or something. So that's all in terms of like how you determine if something is good or not. That goes into what your objective is. So maybe your objective for something like a news feed, which would be something like Instagram or Facebook, would be Did you like it? Did you spend a lot of time on it? This is something that gets a little bit tricky because, people may ask from like an ethical point of view, is like maximizing time spent a good objective for ranked algorithms? Maybe you should be increasing like diversity in some sense, like things that aren't necessarily measurable from a business point of view, like more time that eyes are trained on Facebook equals more ad impressions equals more revenue. So it's pretty, it's a good proxy for interest, but it's not necessarily the right kind of interest that you might want to be promoting. So I think that, as algorithms get more advanced, like the questions as to what sort of behavior you actually want to rank and promote can get a little bit more nuanced. But the basic idea, ranking algorithms have the algorithm and the objective. And so the algorithm can be things like collaborative filtering or just learning to rank with neural networks or other types of personalization engines that are essentially trying to predict, given you, what your score will be for this given objective that you're trying to maximize. And then based off of that, you present the results in that ranked way for you.
So my girlfriend makes the argument that the personalized feeds and the personalized advertisements are good because, she doesn't want to have like car advertisements. She wants Lululemon advertisements. But then my counterpoint is what you were kind of speaking to was it feels like they're kind of pushing us in a certain direction. Like they're kind of narrowing us. And you were talking about like the breadth of what we are consuming. But I was wondering if like what your views, maybe personal views are in this world of like very directing us towards a product and using our personal user data to influence us to buy things.
Yeah, so I think there are many sides to this coin. It's not as black and white as people can make it out to be. It also depends on what perspective you're looking at it from. So from the business perspective, if in the old days you had to choose which highway to put your billboard on and whoever passed by that billboard would see your ad, maybe not, it's a very inefficient way of doing your advertising. So if you're a startup or you're a small business and you have a limited budget to spend on advertising and you want to basically get your message out to those who will most likely respond well to it or want to see that ad, in the case of your girlfriend, Lululemon, not exactly a mom and pop shop, but you can imagine, like, let's say there's like some new, one of my friends actually from college, he started this, he still has it, but this is a carbon fiber guitars, travel guitars. They're meant to be indestructible in some sense. And they're called closed guitars. Everybody who's listening, so go check it out. But so like I helped him advertise on Facebook when I was there. And for him, like they had a limited budget, like mostly Kickstarter funding, and they wanted to reach out to people who are interested in this fairly niche market of travel enthusiasts who also like playing guitar and don't want their guitar to break. So, for the masses, really, I don't know, maybe like 0.01% of people on Facebook will care about this. But if you can find that 0.01% and deliver this ad, then you can actually get a very good return on investment for advertising. So this is really what like companies like Facebook or Instagram, which have a user base, a active user base that they also, can follow a lot of the movements on, so that you can essentially know what people are interested in. That's very attractive for people who want to spend, make sure their dollar is well spent in terms of who they're giving their impressions to for their ads. On the other hand, which is, I guess, some more of a meta point, is that, well, this whole sort of algorithm has, I think the dynamics are interesting in terms of like, when you start interacting with some type of content, it can lead you to interact with more of that kind of content, because you can imagine that there's a cold start problem. Like, okay, the first thing you start interacting with will set you on a path, because basically your algorithm will think that you're going to be in this sort of group of people, and then you're going to get more content within that group of people, and basically it's going to be self-reinforcing. You're going to continue interacting with that stuff, and then eventually, you're going to see more and more and more of it. And if you look at, like, say, the Social Dilemma, like the Netflix documentary, there's like this segment where this kid is like following like some very conservative news outlets, and then or like conspiracy theories, and like this gets fed more and more conspiracy theories because that's what he interacts with. And eventually all he sees is conspiracy theories, and then things are out of control. I mean, you can self-impose like different priors. For example, like, okay, if a new user come in, you don't necessarily have to pigeonhole them into the first thing they interact with, because you know basically that, okay, well, they haven't interacted with anything, so maybe let's not give any of the few first interactions that much weight in this algorithm. Or maybe let's just at first feed them like a diversified feed and then naturally see where they fall into. And these are all sort of like band-aids that you can put over the problem. But I mean, in general, I think the question about like the dynamics on social networks and like where the algorithm takes you is an interesting research question in itself. And things that like, sociologists can, opine on better than I can. And sort of what fixes, or it's hard to even say if it would be a fix or not, but what different strategies one could take in terms of like objectives to add to algorithms or efforts to disincentivize these sort of, instabilities would be, something that, I think big companies have even been looking into because they can afford to, so. Yeah, in terms of like whether it's a absolute good or an absolute bad, I mean, I think there's no concrete answer.
I'm not sure if you've listened to any or read any of Yuval Noah Harari's work, but he talks a lot about how basically personal user data and big data in general is going to be the commodity of the future. And I mean, that's kind of the way it feels like. So from my understanding, in Facebook, when you log on, you're basically like a little node. And then over time, as you interact with other people and their platform, they associate more and more things with you and they kind of lob things on with you. And then they take that information, or maybe they'll generalize you into a certain group, and then they'll take that information and they will sell it to advertisers. And so I think a lot of the problem is that when the people logged on to Facebook for the first time in 2007 or whenever it was, they didn't understand that they were the product. And I think that now increasingly more people are realizing that, but I think people are having a hard time struggling with how to deal with that they are the product, that their information is being sold off to advertisers, and this is kind of the back and forth that a lot of people are having. So I mean, what do you think about that? What do you think about big data?
Right. Well, I think it's important to be careful exactly how you phrase things because, for example, if you say that people are being sold off, that's actually something that would be sort of more implied by like Cambridge Analytica comes in and gets people's data from Facebook and then sells it to other people. Whereas, Facebook actually doesn't sell people's data. They sell services that act on people's data. So it's more so of saying like, okay, first off, like advertising has run America and the world for well before any time social media and other sort of, interactive technology platforms have come around. I mean, even when you look at elections, like you have people who sell their services as strategic consultants who will tell you about the demographics that are, as specific as white suburban soccer moms, right? So what sort of things will candidates tell these people such that they will vote for them? And what, advertising agencies are directed around the sort of like think groups where you get in like a sample of users and you ask them like how their impressions are based on if you show them this or you show them that. Like at the end of the day, people are trying to sell everybody something. So the way that Facebook or other social media companies or other companies that have access to user data or user interactions is, or maybe to simplify things, their main revenue would be through advertising, for example. Their sort of value that they're advertising is that, look, you give us content that you want to advertise and we can figure out who wants to see it most. And however we do it, like whether we're a social media company or whether I'm just a advertising firm, and I have already done my internal research to know like who wants to see your advertisement for Tylenol or for vacuum cleaners, it's the same sort of thing at the end of the day in many ways. I mean, in other ways, it's different because, all right, like it's less explicit if you're like signing up to be part of a focus group at a advertising firm. Then you know that they're studying you and your behavior so that you can sell to other people like you. When you're joining a social media platform, you don't immediately realize how like your interactions like do help benefit, say, a company that is trying to sell ads, whether indirectly because like, okay, even if it isn't directly for ads like me, if you can identify people who are similar to me and you're not even showing me ads, but you know what kind of stuff I like, and you can infer if there's somebody similar to me, then in the same way that you take a focus group of soccer moms and see what they like doing, then other soccer moms will probably generalize to the same interest. So, anybody who's interacting with these social platforms are giving advertising agencies, in this case, the social media company that's running the platform, information about their patterns, what they like, what they don't like, and that can help you drive ads. And that's what gives revenue. And that's why a lot of startups that just have interaction freemium or free platforms, derive a lot of their value from. I mean, whether or not you should be aware, I mean, I think it's true that most people aren't aware. Whether they should expect to be aware, I don't know. Like, it's just, but it's a little bit more nuanced, I think, than just the breakdown between people being the product, which is a very like intense and sensationalist way of putting it, versus like a more modern way of figuring out what people want to see than it used to be, say, 50 years ago.
Can you give a little synopsis of what happened with Cambridge Analytica?
Oh, well, I mean, I don't even necessarily know myself. I just followed around from as much as a different layperson would. My impression, which could be wrong because I haven't looked into it for a while, is basically that so Facebook allows developers to plug in to Facebook. So, for example, and this is back in the day, things have changed since then. But back in the day, let's say you had an app and you wanted to enable like a Facebook login, or let's say you were a dating app, like a popular dating app called Hinge, operates by having access to your friend list from Facebook, and if there are other people who are also friends with you or friends of friends, like they can sort of like look at that social network and sort of use it for their own purposes, which are different from Facebook's purposes, but essentially it's saying that, okay, let's use this friend network to sort of infer not what ads you want to see, but what people you might be interested in dating. That's the Hinge platform. And so, developers can use Facebook. They allowed plugins to basically use the social network for their purposes. I'm not sure if it was for a cost or not. It depended. And then I think the idea there is that in that contract with Facebook that you're not going to sell that data, or that there's some terms in terms of like, these are the terms, like, when you use a service of anything, like there are terms of conditions that you sign when you use them that you won't abuse them. So for example, if you use Netflix, like they have a term that you're not going to pirate the movies by downloading them and then selling them, right? That if you put it on YouTube later, that would be a copyright infringement. It's against the terms of Netflix. They will probably terminate your account and sue you. But again, like, okay, let's say that you are a artist and you have your movie on Netflix and somebody comes, uses Netflix, downloads the movie from Netflix and then sells it to everybody else for free, or just, pirates it in some way, then yeah, you'd be super pissed off if you were that user. But again, is this necessarily Netflix's fault? Well, maybe they should have had better protections that wouldn't allow you to download that movie, and they do. I think they don't. You can't screen share, you can't screen capture. You don't necessarily download movies to YouTube. It makes it hard to download movies from YouTube. So these would be sort of things that, like, if you're a company that is hosting these sort of like sensitive data or things that you wouldn't want people being able to get their hands up illegally, whether or not it's like, even if it's against your contract, you can't just wave your hands and say, oh, well, we told them not to, but they did it anyway. Like, you have some, basically some moral or responsibility to make sure that the data that people are giving you, or things that you're entrusted with, are in good hands. So I think the basic idea behind Cambridge Analytica is that they're able to come in and like sort of mine data from Facebook without necessarily Facebook being aware of it, and then using it for nefarious purposes. I'm actually not sure. I haven't been following that, but it's unclear exactly what the outcome of what they actually did was. But I think that at a high level, that's the basic idea.
Yeah. So I wasn't aware that there is like an intermediate. So it's not Facebook that's selling person. I don't want to.
No. Facebook didn't sell the data. It was enabled to be mined from Facebook.
And it's always these intermediate companies working with the advertisers. Like it's always an advertisement firm paying Facebook money somehow to get that information and then push it off from there.
Like, Facebook has many different products, and to avoid this being like a complete conversation just about Facebook, but just real quickly. So like Facebook has many different products. Part of those products are just advertising, in which case if you're a company, you can create an account on Google, not Google, but Facebook ads or whatever it is for Facebook for business. There's I forget what it's called, but basically it allows you to sort of create and deliver ads to people on Facebook. Put up your credit card and pay for it. There's also Facebook for developers, which are people who are making third-party apps that use Facebook plugins, whether it's Facebook for authentication, so you use it to authenticate into your app, but use a one-time login, so like in the same way Google allows you to log in from Google to a different app, which isn't actually Google, but allows you to use your account basically as your login. Those are things that, like, in terms of software, these are like APIs. APIs is basically like an interface that the company will expose to third-party developers that want to use some features of Facebook in their app. The Hinge example is one of those. Like the Facebook graph is an example of a different product that is distinct from advertising. There's no ranking. It's just like if you wanted to query, can I query, if Max has given me permission, can I see your friends? So let's say I go to your profile and I'm friends with you on Facebook, and it's essentially the same thing as you giving me permission to view who you are also friends with. And then, okay, I can start looking at that and I can see who you're friends with. I can see who other people are friends with. And then based off of that information, if I have my other app, like I might be using that in some way. Hinge's way is to recommend people for you to date or for me to date. And those are all based off of like, when you sign up for this app, you click, do you give permissions to allow access to Facebook's blah, 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 blah. And then you say yes. And then it says, okay. And then people often just sort of like click, okay, no matter what. People don't read these things. People don't care. But, if they give you permissions and they actually do more than what they were sort of like inferring or what you would expect them to do, then yeah, you can get these sort of runaway scenarios where they're actually using a lot more data than you intended. And like, it's basically like it's not a leak because there's no breach of security, but it's more of like an unintended, like, okay, somebody walks by your house and asks if they can walk in and you're not paying attention and you say, yeah, sure, walk in anytime you want. And they come by and then they're actually looking around and they're doing a lot more than you really wanted them to do. And you can't like call up the building manager and say somebody broke in because it's like, no, you told them that they could come in. Like that's the intended purpose isn't going to be. And then, maybe you say like, oh, well, actually, you should have been watching out to make sure that I didn't do that, So
that's what people, they pressed accept on the first day they signed up without even realizing it. They allowed
a lot of people just don't read. I mean, how many?
Yeah, no one reads it.
Or things have you read in the past?
Yeah, no one.
Probably not, so.
I mean, it's kind of a scary example, but I mean, that's crazy. All right, moving away a little bit from social media, I was hoping you could talk a little bit about how text generation works and some of the processes behind that, and maybe in what senses, what scenarios it would be used for, and why it's so important.
Yeah, so text generation, big rage nowadays, lots of hype, especially coming out of OpenAI's GPT-3. I mean, at least in the last 5 years, I want to say, 5-10 years, really just 5 years, text generation has gotten a lot better, mainly through just pushing the usage of these really large-scale pre-trained language models. So language models essentially are these big neural networks where you look at a bunch of text and you try to predict, given a sequence of words, the cat sat on the, predict what word comes next. And so there's lots of text out there that you can use to sort of model the way that language is. So you can create like a probability distribution over which words comes next. And through the process of doing this, you sort of learn a lot about language. Like you learn a lot about like what words, what nouns come, in structures of, if you're looking at languages, you can know that like the ordering of these sentences tend to be like subject, verb, object instead of like otherwise, and what sort of words select for other words in terms of like determiners or non-determiners. There's lots of like grammatical phenomenon that you can sort of unwittingly learn by just modeling the way that language appears on the web, in books, everywhere, just by reading it and modeling like what word comes next. And so these huge language models that are coming out of these big companies like Google or OpenAI are mainly just like really, really large models. So they can have, by really large models, I mean they have a lot of parameters or a lot of capacity to model really complex phenomenon. And they're trained on a ton of data. So like you can take the entire web, like terabytes of data, however many gigabytes, that hundreds of gigabytes, maybe terabytes. I'm not entirely sure what the size of the most latest corpus that people train on. But just a huge amount of text is trained for a huge amount of time, use a huge amount of energy and compute, and then you get this language model, which is now just, interestingly, there's a lot of interesting research questions one can ask about how it sort of like, what sort of knowledge it sort of learns by doing this semi-supervised task of just predicting which word comes next. But it turns out that they really enable lots of cool things in the, not just for text generation, but it turns out that these things are also really good transfer learners. Transfer learners is that you train a model on like this language modeling task, then you take those same parameters and then use them for a different task. This could be something like question answering or translation or something like that. And it turns out that they actually help a lot for those types of tasks as well. So, a lot of natural language processing applications have benefited a lot from these really large language models. I think that like true language generation tasks are still not quite in the mainstream. Like people are working on chatbots, people are working, Google Translate is a really good example of a generation. It's more of a sequence to sequence task, so it's not exactly just like generating freeform text. It's very structured. You give a little input sentence and it generates an input sentence, an output sentence. So like GPT-3, people have been amazed at like it, generating articles or whatnot. And I think the most sort of outwardly like impressive thing that just looking at it is that it's very coherent. So in the past, it's been really hard to generate text that is grammatical and sounds right and is coherent in terms of it's not just talking nonsense, like if there is like a flow to the dialogue. So like it's basically discourse instead of just like spitting out highly likely phrases. So those sort of things are just, impressive from a layperson's point of view, just looking at the type of text that it's hard to tell if it was written by a robot or a human. But even more impressive is also like if you go sort of figure out what sort of behaviors or knowledge these language models have sort of learned just by reading lots of text on the internet. That's also interesting in terms of what you can then use that for in terms of transfer learning. I think people have also like worried about like, okay, you have a lot of text on the internet and it learns things. Maybe it's learned things it shouldn't have learned. Like sort of more dark corners of the web that maybe inciting like biases into these models, and so that's another thing that people also look at.
Is there any way to get around that? It seems like there kind of isn't. If it's being trained on, it would have to be only specified to only take in certain curated articles. But is that like really what we want?
Yeah, it raises a lot of hard questions. One question would be in terms of like regulation, like what sort of ethics would go around, like do you want to enforce machine learning models to like be trained only on politically correct speech? I imagine that different groups of people would have different opinions on this. Do you want to make sure that certain biases, I think it comes down to what you're using it for. So I'm not like an ethicist, so I can't really opine in any sort of concrete way, but I mean, so for different applications, people have come up with sort of like ad hoc solutions to try to measure, say, things like bias. Like, okay, if I'm in a job hiring or job candidate screening application, I want to make sure that there isn't like some uneven odds of, say, some attribute that I believe to be uncorrelated with performance. So let's say it's like gender or race. Now I'm hiring for jobs. Like I want to have equalized odds, marginally. So over the entire population, the given like the same other attributes, just holding out like unconditioned. So let's say you have like the probability that this algorithm is going to say that you're a good candidate to hire, holding all things equal except for race or gender. Like I want those to be equal, regardless of what category of race or category of gender you identify with. So, and that would sort of, would consider that to be a somewhat fair algorithm for that application. Now, obviously, if you go to other things, and it may not be equalized with respect to like what flavored ice cream you like, but maybe you don't really care about that for this particular task. It's not a protected attribute in some sense.
Mm-hmm.
But I mean, it's sort of like you have a balloon full of water and you squeeze it in some ways, and like you squeeze one area and the rest of the areas pop out. So it's like as you sort of do things to this sort of thing, which has these very complicated dynamics, other behaviors emerge. And just because you've squashed one part of it down doesn't necessarily mean that another problem has emerged. So, I mean, in general, it's a very active area of research, like how to make fair algorithms and equalized odds algorithms and unbiased algorithms. So, it's an important problem.
You talked about knowledge, like these algorithms having knowledge. To what degree do they?
Right. So, okay. I mean, one easy way. So I was talking about language modeling before. So you have a sort of nonsense sentence like, the cat sat on the mat. That's not really like a knowledge statement, but if you have a good language model that has been trained on lots and lots of text, like you can by just looking at which words are most likely to come next. Like let's say that we had the sentence, Barack Obama was born in. What word is most likely to come next? Now, if you've been trained on a lot of text and you've sort of seen this before in some sense, then you might use the models that are inside this, the parameters that are inside this model will make Hawaii very likely because it's sort of read this before. In the same way that you read a textbook on biology and you remember that certain things like the cells of mitochondria, right? So if I then pose the question to a language model, like the main components of a cell are, and then ask it to generate the next parts, it will probably generate things that are actually within that cell. Now, okay, the question is, does this constitute knowledge or not? Well, for the purposes of answering questions or just generating text, if it tends to be correct, then you can say, oh, it tends to know these things. Now, is it really knowing these things, or is it just generating the most regurgitating, per se, the most like likely words that follow this particular input sequence of phrases? It's, I guess it's like memorization in some sense versus generalization, like being able to like ask questions or read things and combine facts that weren't necessarily within your training data. Whether or not like they can generalize well, which actually for these larger language models like GPT-3, there's evidence that they actually do generalize quite well. But that's an example of like what it means to have like knowledge built in. There's basically things that you have read before, which are baked into the parameters of this model from training, that then have distilled part of the text that you've fed to the model. That's basically what I'm saying.
Cool. You mentioned sequence to sequence, and I've heard end to end. Can you tell me what that is?
Yeah, so end-to-end is different from sequence to sequence. So end-to-end means that from input to output, it's like a fully automated differentiable process. Typically differentiable, not necessarily. So basically, you can have pipelines. So let's say that I had let's say I want to do a question answering system. So a question answering system, just to give you a brief overview, is this basic idea where you have a question come in, like again, if we looked at this, where was Barack Obama born? All right, and now we had to devise an algorithm to get you that answer. So one popular way of doing this is to like chain a retriever and a reader module. So retriever module would say you do a quick Google search to get some relevant web documents for this question. Like you Google where was Barack Obama born, it will give you some top hits. You click on these top hits, and then let's say you give it to another neural network, which is then takes in that text and reads it and then gives you an answer, presumably Hawaii. We won't focus exactly on how it reads it and how it gives that answer or how the Google search works. We're just assuming these are two black box systems that you do one first and then you pass the results to the other. And one system doesn't know anything about the other one. They're just, you get web pages, the web pages come in and you get answers. And the other one is you get questions and you return web pages. Okay, so that will be a pipeline. It's these two parts that you can optimize independently of each other. Now, something that would be end-to-end is to say that, okay, well, actually, I don't necessarily want a Google search. I want a Google search that is optimized for my particular model that is taking in those web pages. So let's say, for example, that this was Google search in Spanish or Google search in English. I could give you the same web pages based off of a Spanish Google search, but it wouldn't be very useful to you because your reading comprehension skills in Spanish aren't really that great. So you wouldn't be able to get the answer. So you would actually want to go back and say, Google, give me this in English, or give me it in simple English. You might like click on the web pages that are formed. And this is an example of you actually communicating to the algorithm, which is feeding you these web pages to make them more optimized for your process. So things that are end-to-end basically start from input all the way to the final output and optimize that entire process. Typically, this is because you chain together these neural networks that are differentiable so that you can take gradients, basically different mathematical operations that tell you if I tweak this parameter in this way, it will have an effect way down the line on this parameter over here. And ultimately, that will get me a better answer. So that's the big, obviously these things are more expensive because now and they're not always possible. For example, maybe you rely on Google search. I don't really know a automatic way of, optimizing Google search because, well, they don't expose that to me. So one thing I could do is optimize the way that I rewrite the query. But then you have to go into more complicated algorithms to know how to do this end to end. You really would need reinforcement. So sequence to sequence, in contrast, is just a term for you have an input sequence come in and you have an output sequence go out. So normally machine learning algorithms take in X and output Y. In some cases, X could be an image. In other cases, X could be a number, and then you output another number, Y. For text, generally you have a sentence, let's say it's machine translation, you have a sentence come in. So the cat sat on the mat, and now you want to translate that to another sentence, which would be in German or something. So that is the sequence to sequence aspect of it, which is the input, and it's a term for what the input and the outputs look like.
So as we're talking about transfer learning and knowledge, do you think? I mean, I think when people are fearing this artificial intelligence, they're thinking artificial general intelligence, which is having some true ability to reason and have some real intelligence. So do you see that coming thousands of years from now? I don't know, any thoughts on that? And do you think that there needs to be big breakthroughs, or do you think just incremental increases and improvements of what we already have will get us there?
Lots of things happen in thousands of years, and that thousands of years ago from now, one would hardly be able to predict the type of information age that we live in. So 1,000 of years from now, I would imagine that we have some sort of if not general intelligence, and something really, really close to it. Even in the past 15 years, things have progressed quite astonishingly in terms of machine learning. Obviously, we're nowhere near close to what people would call general intelligence, but we're getting a lot better at sort of devising things that are good at narrow intelligence, so things that are very good at specialized tasks. putting those things together, I imagine that, there's tons of different, like, if you go look at, like, what research needs to be done in AI to sort of get there, there's, like, missing pieces that still need to be filled in before, anyone can really claim that there is, true reasoning in this sense. Part of that is just how to measure it, right? So, like, how do we know that something is actually sentient, per se? So you asked a lot about what it means for a language model to have knowledge. I mean, if you go back to, say, the Turing test, it is just like trying to discriminate between whether you're talking to a human or whether you're talking to a machine. That was considered a grand challenge towards, like, general intelligence of some sort. But, those things, as we know now, like, okay, we can potentially beat the Turing test with, say, something like GPT-3 just because it generates really coherent things. Now, someone who has made GPT-3 knows how it works. Like, they probably wouldn't tell you that it's generally intelligent. They may not say that it's intelligent at all, actually. But to a layperson who's just interacting with it and doesn't really know much about how it works, they would think, oh, for all intents and purposes, I don't know who this is. It seems like it's human-like. So, I mean, partly just coming up with better ways of probing and analysis, and, like, in the same way that we have standardized tests for us, like, standardized ways of testing what a artificial intelligence and machine learning neural network model knows and what it doesn't know, and whether it's actually doing different sorts of reasoning or not. Like, a lot of research nowadays, like, it's very hard to get very systematic benchmarks to measure performance on these things, because it's very easy for neural networks to exploit patterns in the way that these tests are made up and exploit them so that, they pick up on some pattern that is unrelated to the actual task, but allows it to answer very well. So you can imagine, like, okay, if you're trying to do, like, images of breast cancer and not breast cancer, if you're trying to, like, see if you can train a machine radiologist to do better than a human radiologist, well, maybe it doesn't necessarily detect features that are related to the actual MRI, but maybe there's, like, some labeling or some slight difference in the images in this data set that were collected from people who had it versus people who didn't. A famous example is back in, like, the 1960s when they were developing, I think it was, like, algorithms for image recognition of aerial photos of tanks for Vietnam. And so they had these perceptron models where they trained it on images of tanks and images of not tanks. And then they go and they try and do it in the wild, and it turns out that something which had really good accuracy in the lab had horrible performance out in the field. And the reason was that in the lab, the images they had, I forget exactly what it was, but they had some imbalance between the photos they had that had tanks in them tended to be out in the sunlight, and the photos that didn't tended to be in forests or dark. So it actually picked up on whether it was dark or whether it was light. Now you have a tank which is in a dark forest. Well, okay, it's going to say there's no tank, which is actually the opposite of what you would want it to do, because this is actually the type of thing that you would think is important to be able to tell if it's a tank you can't see. So it picked up on the wrong features. Does it mean that it did a bad job at the task? No, it just didn't really know exactly what was being asked of it. It was being asked to get all of the questions right on the test, and it figured out a way to basically cheat it. So if it was climbing terms, I don't know if you like rock climbing, people like rock climbing, it was breaking the beta for the route, It does it in a different way. It's not necessarily wrong.
Interesting. So when you're talking about these standardized scores, I couldn't help think of Blue Score and basically trying to get some standardized metric to rate the accuracy of machine translations. So last time I was kind of, because this is what I'm doing my science research project on, and you were kind of talking about a better way to do it would be to build a model, or would be to build an algorithm that does the Blue Score's job itself. I was wondering if you could speak a little bit more to that.
Yeah, sure. So talking more about Blue Score, so I mean, it basically, like, this is another example of one of these things which is hard to measure. So you have a translation, and this is particularly hard to measure because even with a translation, And even if it's not making that translation for the right reasons, all those reasons of bias that I had before, those are things that may not generalize well. Okay, ignoring all of that, it's even hard to tell whether it has the right answer or not for the case of translation, because there are many ways of saying things. Like, even in the sentence that the cat sat on the mat, like in English, you could also say on the mat the cat sat. It's weird, but it's still correct. Or you can arguably say the kitten, maybe it's not that wrong, but the kitty sat on the mat.
Laid on the mat, using synonyms.
Yeah, synonyms, different ways of saying it. This is a particularly simple sentence, so there's not that many ways of saying it, but now let's say you had a whole document, right? A very long thing to translate. There are many ways of doing this, right? So, and just because you don't necessarily match the reference that you were thinking of, doesn't mean that it's wrong. So the way that Blue Score sort of works is, it sort of takes all these n-grams, so different sort of snippets of the text, and tries to see how well the thing you generated matches the output in terms of like n-gram overlap. And this is a sort of like, it's a decent way of getting an idea as to how well it is. Like, you can imagine that something that has 0 Blue Score is much worse than something which has 30 Blue Score. But like, it's hard to tell once you get into higher Blue Scores what exactly, like the correlation between really good human judgments as to whether this is a good translation or not, and the Blue Score start to break down. So as systems get better, relying on Blue Score starts to be a problem. If it's uncorrelated, you might actually be incentivizing the model or ranking models that are actually worse at doing translations than the models that are actually good at doing translations. So you start hill climbing on the wrong metrics. One example of something which, an n-gram model would be agnostic to in terms of like semantics, which the sentence was, the cat sat on the mat versus the mat sat on the cat. These are two very different sentences, but they share the same exact words. So many of the same n-grams, like on the mat, the cat, are similar. So you might have a non-zero Blue Score, but it doesn't actually mean that that is good translation at all. So different ways of sort of getting around this. People have been sort of working on this problem a lot in the past couple of years. There's various other iterations of n-gram models, but also people have tried to say, okay, maybe let's just model this as its own problem. So in the same way that we model translation as a problem that we want to solve automatically, let's model evaluation as a problem that we want to solve automatically. So let's get a bunch of gold translations, gold meaning that it's a good translation, and an example of bad translations, and let's try to train a model to discriminate between the two. So now it's optimized. If we trained a model that says this is a good translation, essentially like, do these two sentences paraphrase each other or not? Are they the same, or are these sentences different? And if that model is really good, well, then we can use that as our evaluation metric. And we don't necessarily need to know what it means, but just in the same way that we want to maximize Blue Score, okay, let's just maximize the score of this automatic model that we can train. Now, you want to make sure that that automatic model doesn't have any, inconsistencies in some areas, and you want to make sure that it actually is well correlated with human judgments. But again, this is part of the efforts to just sort of, Blue is an easy metric to use. It worked well for a long time for all of the machine translation efforts. It's been on for quite some time now. So, but things have been getting better, and as things get better, you come up with better ways to evaluate things. So, in the same way that for our tests, that we do for evaluating, how smart kids are, or how well they know materials, the ways of evaluating these things get updated all the time. So there are some ones which are decent proxies but have problems. And then, as things get better and you want to tell and you want to get a more balanced view that you can actually depend on, then you get a better test. So Blue Score is okay for just sifting through bad models versus good models, but between good models and better models, you want a better metric. So this is the example that I was talking about with this automatic metric is it's devised. There's a Google paper which is called BLERT, which is essentially a trained, optimized Blue Score. It's not a Blue Score, but it's a successful BLERT.
Awesome. Yeah.
Recent research, so none of this is definitively established, by the way.
Yeah, but that seems like the way that seems like the direction we should be moving in.
Yeah, it's a good idea. And I mean, there's many other sort of variants and sort of, similar ideas to that one example that go in that direction.
Mm-hmm.
Really, the direction is away from trying to directly match references in the case of machine translation, but more broadly, just different ways of more flexible evaluation strategies. There's other examples as well, and like basically the way that research will pan out is that over the next 5 years, like people will sort of naturally figure out which ones are most stable and which ones aren't. But again, it's an active area of research.
Awesome. Well, I don't want to go backwards, but you touched on reinforcement learning a little while ago, so I was wondering if quickly you could give a little overview of the different types of learning that goes on with these algorithms.
Sure. So at a high level, and obviously there are subcases as well, but the sort of major forms of learning would be reinforcement learning, supervised learning, and semi-supervised learning, or an unsupervised learning, really. So it's really unsupervised reinforcement and supervised. And supervised is a mix between unsupervised and supervised. So supervised is quite simple. It's this general paradigm where you have inputs and you have outputs, and you basically fully differentiate the path that your model takes from input to output. So this would be the case where you have this model which has all these little knobs, and you know for in given input, you feed it through your model and it gives you a certain output, and you know basically how bad your output was in terms of it can match exactly a particular, let's say you're trying to generate a particular sequence. And this is something which is actually interesting for like the supervised case of if you're just trying to maximize matching exactly generating some sequence. Well, you know how your model's parameters affect its final outputs in this case where you have an exact reference that you want to generate. And then you can sort of tune these knobs to know if you turn one of these knobs, how it's going to affect your final output. So I think an analogy, I'm not sure if it works, but it's one I like using, is about like baking cakes. So a supervised way of baking a cake would be you bake a cake, you give a first attempt at it. You put in some inputs, which is this flour, this eggs, this salt, this sugar, and you get this cake. And then let's say your parents come and tell you exactly this cake has too much sugar and too little salt, and it could use the same amount of flour. That's good. Then you go back and you start dialing your knobs where you put in a little bit less sugar and a little bit more salt, and you keep the flour the same. And over this iteration, you can imagine that you'll converge quite quickly to what a good cake would be. Every time you come back to your parents, they tell you, this was bad, this was good, do more of this, do more of that. And then you go back and figure out what actions to take such that that is satisfied. Reinforcement learning, on the other hand, sort of doesn't have that same communication between like knowing exactly what needs to change in order to maximize your output. Reinforcement learning is basically just a thumbs up or a thumbs down. Like you bake your cake, you throw some things together, you go to your parents, and they say, this is bad, man. You got to fix this. So then you say, okay, well, that's not really helpful, but you go back and you mix your things together and you come back and you say, oh, this still sucks. This is horrible. Then you go back and you come back to them, you make a new cake, completely revise your recipe, and they say, okay, this is a little bit better, but it's still not that good. And you do this many, many times. And over time, you'll sort of learn that the cakes that had a lot of sugar, your parents didn't really like. Cakes that had too little sugar, they also didn't really like. And there was somewhere that was just right in between. It'll take you a long time to get there. You'll have to do many, many iterations. It'll take a lot longer than in the supervised case. But in the case where maybe your parents didn't know how to bake the cake, they just knew whether it was good or whether it was bad. They didn't have to tell you what to do, right? So in some cases, this is actually much more flexible because they just tell you whether it was good or bad, and you figure out the rest. So there are many objectives or many types of problems in which you can't fully supervise them, but you can, say, give you a reward signal as to whether thumbs up, thumbs down. Unsupervised learning is basically just, in a high level, the most common case would be finding patterns in data. So this would be something like clustering. So if you're going back to this example of social networks, you could do an unsupervised algorithm, which would basically identify like, neighborhoods or user groups that are all like in the same community. There's no sort of supervision for this. I'm not telling you this is a neighborhood, go find it. You just sort of look at the structured data and you would sort of see, okay, these people interact with each other very often and these people don't interact with each other very often. This is probably one group of friends and this is another group of friends. I'm just like looking at a visualization of this, or just using some algorithms to automatically pick up on these patterns, you can sort of do some, say, data science per se, on that latent structure. So like clustering algorithms are a good example of that for unsupervised learning.
Awesome. So right now we're having this kind of like reverse trend, or at least in AP Modern Euro right now, and we're learning about just like this gradual improvement that we've basically been on course for so long, like this push towards more equality, more like a little bit more balance between like the rich and the poor. But it seems in like the last decade, like since the turn of the century, we have kind of been going in the opposite direction. The gap between the elites and the poor people, especially in developing countries and maybe even between developed and non-developed countries, is widening. And I know you hate to extrapolate, so I'm not going to ask you to give an economics answer, but I was wondering what your perspective is on the role technology plays in this. So, I mean, I'm thinking, and I know it's not going to be black and white, but I mean, it seems like the owners of these technology companies are gathering more and more money, and that's creating an even smaller or an elite, and it's widening the gap and it's moving even farther away. But then on the other hand, I'm thinking, okay, well, why don't we bring like coding classes into some lower income communities to kind of like counterbalance that effect? So I was wondering what your perspective is on this balance between how technology is going to interact with inequality, I guess, and influence it.
Yeah, I mean, as you said, it's a very hard problem to answer. I'm not the, say, most expert person to give an opinion. I mean, in general, I think that technology is good in the sense that, like, the rise of technology does provide a lot of opportunities. So, I mean, you can even sort of think about, okay, what's the sort of impact of Facebook, Google, things like that in like more remote or third world countries. So, part of there is that there were initiatives, at least, within the last few years, about like getting internet access to more people in these countries. For like companies, like internet giants like Google or Facebook, this is good because just more users, more eyeballs, more ads, in a very like coarse way of saying it. But a side product or a byproduct, which is ultimately most likely good, is that there's more internet access to more people in the world. And so education generally is considered to be one of the most powerful tools and powerful opportunities that you can give people. It allows them to become more connected with the rest of the world, have access to different types of jobs, different types of opportunities. In general, just education is a really, really good thing. Now, in terms of like how technology will change the job sectors, hard for me to tell exactly. I mean, technology in general has been changing jobs for the last, hundreds of years. The Industrial Revolution, for example, changed the way that the world really treated jobs and what type of jobs opened up, like, software engineering without even the advent of machine learning has been something which has been, on the rise for the last 50 years, not necessarily for, just the last 15 with like the modernization of neural networks, etc. So in general, like technology changes what jobs are available and what jobs are in demand, and, which types of specialized workers are most wanted or in demand. And I think the sort of implications that what jobs close off of, it's true that, with more efficient farming technologies, you don't need as many farmlands, you don't need as many farmers. or for energy, for example, when you go into clean energy, you don't need as many coal mines. By that, you need more nuclear engineers and you need less coal miners, right? So that creates a problem for the coal miners because now they need to find new jobs, or they can't do jobs their fathers or mothers did for the last 100 years or 200 years, whatever it was, what they know. So, I mean, at the same time that technology closes off some job sectors, it also opens up many more. What those exactly will be and how much education they will require. So maybe how hard it is to access them from, you can argue that, like, say, okay, there's lots of uneducated jobs that were easy to get, like you just go grab a shovel, go to the coal mine. That's easy to get. You don't really need to go to school. But if education is easier to come by and we have more efficient ways of educating people have cheaper ways of getting access to, like, the internet and to just ways of learning to get more specialized jobs, then maybe it won't be as hard to maybe the barrier to entry for different job sectors won't be as high. So it's hard to predict how these things will change. I mean, obviously, like, if education doesn't rise, then there will be big problems because it will now essentially be only the educated who have easy access to jobs, and the ones that are uneducated, the jobs that don't require education can be automated, which will create a big problem for people who have less privileged access to education or fewer opportunities. So, I mean, I think it's really important to, as a society, not to make any sort of bold or arrogant claims, or not necessarily arrogant, but just like, widespread claims is that, as technology improves, we also have to improve, like, societal aspects of fairness and equality. At the same time, this is also why working for equality and fairness with an algorithm is also important. So, but I mean, in general, you can't do the two of them independently.
Yeah, it seems like getting maybe some more technical education earlier on is going to be really important, and just getting that education to as many people as possible and in the most accessible form possible, because so many of these jobs that are going to open up are going to be in the tech space.
Yeah, I mean, they don't necessarily even need to be technical in the sense that, like, people need to do math and physics quizzes. But I mean, just even in terms of, like, design or art nowadays, like, okay, like, the ways that art and design are taught, like, they're computer aided in the sense where you have, like, technology, like, it's just proficiency with using, say, laptops or these maybe tablets or other aspects of, like, technology that are, like, new and exciting and can help you do things that you just have to be familiar with. Now, if you don't have access to that technology, you don't have access to a laptop, you don't have access to a tablet, you can't do that. If you have access to it, you don't necessarily need to be, super educated in terms of, like, your calculus skills. You just need to be educated in terms of, like, tech fluency. So, a lot of these things aren't like as like, oh, we need more STEM. I mean, obviously more STEM is helpful, but, like, even within humanities, like, there are other jobs that this stuff creates, or just iterations of those jobs. Like, if it's not art, if it's, like, politics, like, it's sort of painful to hear, like, politicians nowadays try to regulate different tech when they have no idea, like, when they have the interviews of, like, Mark Zuckerberg or Sundar Pichai, the CEO of Google, come in and, like, talk about it, and they have, like, no idea how this stuff works. It's, like, painful to hear them try to, make legislation on this kind of stuff. But when people are just more educated in terms of, like, how technology works, and not necessarily, like, make technology, but they know how it works, then you can have other jobs that use that stuff without necessarily knowing, like, what specific neural network algorithm is running behind it and what a gradient is. But you can still be quite functional at your job.
Yeah, it's brutal to listen to those interviews. Technology is increasing exponentially, but human nature, I guess, is increasing linearly, and politics and everything else are kind of following and trying to skate and catch up, but having a hard time to do so. God. You hear about AlphaFold 2?
Yeah, I did. It's a very impressive result.
You know about how any of the technical aspects of that system works?
I'm not super familiar. I mean, I know it at a high level. I believe it uses the same sort of algorithms behind like AlphaGo, which is essentially just like very large scale, like Monte Carlo tree search is an algorithm that's used there. It's a different sort of like reinforcement learning, where basically you explore a bunch of different states in a probabilistic manner. And as you basically run more and more simulations of this stuff, you learn a lot more about like, okay, the way that the game works for Go, or the way that the proteins fold for protein folding. I don't know exactly which algorithm they ended up using for AlphaFold, but I mean, the main idea is that you just have a lot of compute, and you have some advanced algorithms that just explore a lot of possible outcomes and simulations, searching through all of these possible like folding scenarios, or with Go, all the possible games that you can play, such that you get the best strategy, and that you can evaluate essentially like with Go or folding or whatever it is. When there's an intermediate state, you have to evaluate what to do next. And one way to evaluate what to do next is to play a lot of games. Practice makes perfect in some sense. And if you have a really good way of exploring what will happen if you do this, if you do that, then you can learn very efficiently, instead of like iterate through this really exponential search space. And I mean, and just in terms of like the results are amazing in terms of like their just absolute improvement over the last few years in terms of the protein folding, which, I mean, I'm not a biologist, but I understand that it's one of these grand challenges which has been around for many years. Again, it's not like general intelligence, but it's like an example of a narrow task that is well defined, that is very hard for humans to do, which you can train an algorithm, in this case, this neural network, to do quite well at it.